Okay, this is lesson 9.3, using transformations to determine congruence. This lesson might, at first, seem like a lot of review from chapter 8, talking about transformations, but the point of this lesson is to go beyond just how to do the transformations and determine if shapes are congruent or not. That's our objective. You'll be able to use transformations to overlap figures and determine whether they are congruent. Our first fill in the blank, polygons that are the same size and shape, well, that's the definition of congruent. This means that all of their corresponding parts are congruent. So example 1 says that congruent figures can undergo some transformations and maintain their congruence. Which transformations below maintain their congruence? Pause the video, and I want you to circle one or more of these, maybe all four, I don't know, you decide. Circle the ones that preserve congruence, and then come back and check your work. Okay, hopefully you remember from last chapter that 3 of these transformations, in fact, translations, rotations, and reflections specifically, are what we call rigid transformations. So these 3 preserve congruence. Dilations are non-rigid. So they do not preserve congruence. Now again, I'm not just going to ask you to translate a shape or rotate a shape, but I might ask you, hey, if we look at, in fact, let's use a different color. Let's call this quadrilateral A, B, C, D, and this can be A prime, B prime, C prime, D prime. And I might ask you, are these 2 quadrilaterals congruent? And if you can translate or slide the blue shape so that it lies perfectly on the red shape, then they're the same size and shape, so they must be congruent. And if that's the case, then we can start labeling their corresponding parts, and we can say that, well, since they're congruent, angle A must be congruent to angle A prime, or angle B must be congruent to angle B prime, and we can keep going. These angles have to be congruent, and these angles have to be congruent. Sometimes they mark them with multiple arcs like this. I'll show you a different way on the rotations. But not only will we be marking angles and showing they're congruent, we'll also be showing that their sides are the same length. They're congruent. Like line segment AB is congruent to A prime B prime, or BC and B prime C prime, and C prime D prime is congruent to CD, and you get the idea. That's one way to mark all the corresponding parts, all 4 angles, all 4 sides. Another way you could do it, say when we rotate, you could label the right letters for each vertex, but I'm just going to mark them this time. We could also mark the angles this way. Sometimes they'll just mark it once, so that angle would be congruent to this angle. Sometimes they'll mark them with a tick mark through it, like this angle would be congruent to that angle, or this angle with 2 tick marks is congruent to this angle with 2 tick marks. And this angle with 3 tick marks could be congruent to this angle with 3 tick marks. And again, you could also mark the sides, like this side is congruent to this side is congruent to this side, and so on. I'm not going to mark them here, but you get the idea. You could also mark all the corresponding angles and sides for reflections, and they would be congruent, but we cannot do that for dilations. Okay, so translations are the first rigid transformation we learned about back in 8.1. In example 2, we are asked to find the translation that moves star 1 to star 2, and also the other translation that slides star 4 to star 5. Let's do the first one together. Star 1 is here, star 2 is here. So we're taking the point -5, -1, And we're sliding it or translating it to the point -3, 1. So in our heads, we are going to think about, well, what did we add or subtract to -5 to get to -3? That's going to be the horizontal part of our translation. And then also, what do we add or subtract to a -1 to get to 1? And it seems like we're actually adding 2 to both. So the most common way I wrote it in chapter 8 was the algebraic rule form, where I take some point P that has an x-coordinate and a y-coordinate, and that's on the what we call the pre-image, and the image point, P prime, will end up being x plus 2 because we added 2 to -5 to get -3. And it'll actually be y plus 2 also because we need to add 2 to -1 to get to 1. If you don't like writing it in the algebraic form, you could write it in a shorthand form, T for translation, and we'll just write what we're adding to the x-coordinate and then what we're adding to the y-coordinate. You could also use vertex form if you remember the different forms we used in 8.1, which would look like this. Any of these 3 forms would be sufficient, though. You don't have to write all 3. All right, try to write a translation rule for sliding *4 to *5, and then come back and check your work. There we go. We are adding 3 to the x-coordinate, sliding it horizontally 3 units, but we're not doing anything to the y-coordinate. It stays the same, so y just stays a y, or we're adding 0 to the y-coordinates. Awesome. Let's try rotations. So they give us 3 ordered pairs for the coordinates of triangle ABC. Go ahead and write those down here. And then we are asked to rotate the triangle 90 degrees counterclockwise. Look it up in your notes or on your note card. Find the rule for rotating 90 degrees counterclockwise, and then come back and check your work. All right, so to rotate 90 degrees counterclockwise, each point x comma y will get sent to -y comma x. I want you to apply this rule to these 3 points to get the coordinates of A prime, B prime, and C prime. Come back and check your work for that too, because we did this a lot in chapter 8. There we go. And then if you graph these 2 triangles, your graph should look something like this. Now again, this is chapter 8 stuff. I'm not going to give you a triangle and ask you to rotate it, but when you do your con for this unit, you might be given 2 triangles without being told that they're congruent. If you can take the first triangle, the pre-image, if you can rotate it so that it lies exactly on the red triangle, then they're congruent. But if you try to rotate it and it's kind of on it, but maybe it's not exactly the same size or shape, then you can say that they're not congruent. And that's the idea behind chapter 9 here. Let's try reflections. This time we're given a quadrilateral, but again, we have rules for reflecting over the x-axis. We have a rule for rotating or reflecting over the y-axis. I want you to look those up if you don't remember them and write them down here, and then come back and check your work. There we go. So when we reflect over the x-axis, the x-coordinate will stay the same, but we are going to change the sign of the y-coordinate. And it works the other way too. To reflect over the y-axis, the y-coordinate stays the same, and the x-coordinate will change its sign. Take a moment, pause the video, write down these 4 ordered pairs, these 4 points, and you're going to have to write them a second time because we're reflecting it over 2 different lines. And I want you to apply these rules. So find out what K prime, L prime, M prime, and N prime would be under a reflection over the x-axis, and then do the same thing under a reflection over the y-axis. Once you have 4 new ordered pairs, 4 new points, I want you to plot the image and the pre-image on both graphs. Might take you a while. Pause the video and then come back and check all your work. Okay, for the x-axis, there's your coordinates of your image, and that's what your graph should look like. We're reflecting over the x-axis, this purple dashed line that I drew, and notice that K is 4 units away from the line of reflection, so is K prime. L is 3 units away, and so is L prime. And you could do that for all 4 points. They should be equidistant. Corresponding points, rather, should be equidistant from the line of reflection. Here's the other reflection. So if you reflect over the y-axis, then the image will be there, and that's what it should look like on your graph. Again, the y-axis is your line of reflection, and corresponding points are equidistant from that line of reflection. This was a good review, practicing how to reflect over a line. However, like I said on the last one, on rotating, I might just give you 2 quadrilaterals and ask you, are they congruent? If you take one quadrilateral and reflect it over and it lies exactly on the other quadrilateral, you can say, yes, they're congruent. But maybe you take that blue quadrilateral and when you reflect it, maybe it lies exactly on this line segment and this line segment, but maybe there's a point like over here or something and it's not exactly the same size or shape. Then you can say, no, these 2 quadrilaterals are not congruent. Okay, last part. You might see the acronym CPCTC. We are going to be working mostly with triangles moving forward. That T stands for triangles, and this is what it stands for. Corresponding parts of congruent triangles are congruent. This is basically saying what we filled in at the very beginning, that if you have 2 polygons that are congruent, then each pair of corresponding parts are congruent. It's not specific to triangles, it's for any polygon, but we'll be working mostly with triangles. So I have 2 triangles for you here, and I'm telling you that they are congruent. Triangle ABC is congruent to triangle DEF. So I want you to fill in these blanks. Since we know they're congruent, there are 6 pairs of corresponding parts. Angle A is corresponding to, well, you tell me, which angle in triangle DEF corresponds to angle A? Fill in that blank and 6 more, and then come back and check your work. There we go. So angle A and angle D are corresponding, and they're marked with 3 little arcs. Angle B and angle E are corresponding. They're marked with 1 arc each. Angle C and F are corresponding. Notice how they're marked with 2 arcs. But we can also talk about the line segments. So line segment AB and line segment DE both have 2 tick marks, and that's how we show on the drawing that they're congruent. Same thing here, the ones with 1 tick mark, they're congruent, or the ones with 3 tick marks are also congruent. Last thing, and then we'll be done with the notes. Even if I didn't give you this picture, if I only made this statement, you should be able to fill in the blanks. And that's because order matters. If triangle ABC is named in that order, A and then B and then C, that means A is first, so it has to correspond with D because D is first in the second triangle. B is in the middle, it needs to correspond with E. C is at the end, F has to be at the end too, so C and F would correspond. And knowing that, you should still be able to fill in these blanks. That's it for 9.3. Ask a question at the end of the video, and I'll see you all in the next one.